Have you ever noticed how in movies, when they pan away from a scene or a character, that character kind of stays with you for a moment? Or how when you walk into a room, the door continues to appear even after you've passed through it? These are examples of something called persistence of vision, which is basically the brain's way of holding on to things just a little longer than they actually exist. So why does this happen? Well, it all has to do with the way that we perceive the world around us. You see, our brains do not actually see the world as it really is. Instead, it constructs a model of the world based on the information that it receives from our senses. And this model is constantly being updated as we experience new things. However, this process is not perfect, and sometimes our brain can hold onto information that is not actually there, which creates the illusion of things continuing to exist even after they've stopped existing. One way that this happens is through our visual system. You see, when we look at something, our eyes only see a still image for a split second at a time. It is only by rapidly flipping through these images that we perceive motion. Our brains then fill in the gaps between these images, creating the illusion of smooth, continuous motion. However, sometimes our brains can get tricked into thinking that an object is still there even after it has disappeared from view. For example, if you were to walk past a person while they were standing still, your brain would continue to show them standing still for a moment even after you had passed them. This is because your brain is still processing the information that it received from your eyes when they were in view, even though they're no longer there. Now, this phenomenon isn't limited to just visual stimuli. It also applies to sounds and other types of sensory input as well. This is why you might be able to hear the echo of a sound long after the original sound has stopped. It is because the receptors in your ear are still vibrating from the sound waves even though the sound no longer exists. These components of our perception are key to experiencing films and animation. Well, these art forms actually take advantage of this phenomenon to create the illusion of motion. By showing a series of still images in rapid succession, film and animation can trick our brains into thinking that we're seeing actual motion. In fact, the word animation was derived from the Latin word anima, which means breath or soul. This is because early animators were able to create the illusion of lifelike motion through this technique. But it's not just film and animation that take advantage of this phenomenon. Our brains do it all the time to fill in the gaps in our perception of the world. There are other facets of the brain which fill in the gaps, such as our perception of depth. For example, we can use binocular cues such as the distance between our eyes to help us judge how far away things are. However, we can also use other cues such as the size of an object to help us judge its distance. Our brain will use any information that it can get to create a 3D model of the world around us, even if that information is incomplete or inaccurate. So persistence of vision is basically a part of how our brains work to help us make sense of the world around us. It is a fascinating example of how our brains are constantly trying to make the best of limited information. And it's also a reminder of just how amazing the human brain is. I just realized something. You know how when you take a picture of something and then look at it later, it looks exactly the same as when you took the picture, even though light is not hitting it? Well, that's because our brains are kind of like really bad at turning off the lights. Our brains take in visual input from the eyes, but it doesn't just passively receive this input. It actively interprets it. And we only consciously perceive a tiny fraction of the information our eyes take in. The rest of it gets processed by our brain's visual cortex, which contains specialized neurons called feature detectors that respond to specific visual stimuli like color, shape, and motion. These neurons fire action potentials, which are basically electrical signals that tell your brain what you're seeing. But these signals don't just go to the visual cortex. They also get sent to other parts of the brain that can use the information, like the hippocampus, which is important for memory. So when you take a picture of something, your brain processes the visual information and stores it in your hippocampus so that you can remember what you saw. And when you look at the photo later, your brain reactivates those same neurons, creating a similar visual experience to the one you had when you first saw the thing in real life. But this persistence of mental imagery isn't limited to visual stimuli. We can also experience sounds, smells, tastes, and even emotions in a similar way long after the original stimulus has ended. This is because our brains don't just store sensory information, they also create a kind of internal representation of the world around us, a sort of mental model that we can refer back to later. And this brings me to my favorite part of this whole topic, the fact that our brains do this with movies. Movies are basically just a series of pictures that create the illusion of movement by accessing our persistence of vision. When we watch a movie, we see a sequence of still images flashed in front of us, but our brain's visual cortex interprets this sequence as a smooth and continuous motion. This is because the individual frames of the movie stimulate the same visual receptors in our eyes, but the motion between them activates different sets of feature detectors, which send signals to our brain that indicate how the image is changing over time. By putting two sequential images side by side, the brain can perceive the movement from one to the other, filling in the gaps between the frames and creating a sense of continuity. This is why watching movies feels so much more immersive and realistic than looking at a series of still images. But there are other facets of the brain which do this, like the perception of depth. Our brains can perceive depth even though our eyes only see 2D images. This is because our brains have evolved to take advantage of the 3D world we live in. Our two eyes are positioned slightly apart on our face, which means that when we look at an object, we actually see two slightly different images, one for each eye. Our brain's visual cortex compares these two images and calculates the difference between them, which gives us information about the object's depth and position in relation to us. So yeah, the persistence of vision is a pretty mind-blowing aspect of how our brains work. I mean, we can experience things mentally long after they're gone, and that's kind of crazy. It is a testament to the amazing capabilities of the human brain, and it makes us wonder what other things we can experience mentally that we do not even know about yet. Dreams are pretty crazy. I mean, it's like we're living in a dream world, but like literally.